Welcome back, everyone. In this lecture, we're going to start going through the Walkthrough Steps workbook solution. I want you to keep in mind this is just an example solution. There's basically an unlimited number of ways you could have gone through this project, but in this case, we're going to go through the steps in the workbook. Let's get started. Okay, so here we are at the workbook. Lots of different things to get started with on the gameplay aspect. What we're going to do in this lecture is just go through these various steps and then fill out all the cells and see if we can create some logic at the end to actually get the game running. So here we see the game, and we want to set some imports and global variables. So global variables, those are variables we're going to be able to reference in other functions and objects. So we first wanted to import the random module. That was actually already done for us, and that's going to allow us to shuffle the deck prior to dealing. And you can check out the useful operators lecture if you want to review about how to shuffle from the random library. But what we want to do now is declare a couple of variables to store the card suits, the ranks, and the values. And you can develop your own system, but we actually have a lot of the code here for you. Where suits, we're going to set it as a tuple. So I'm going to copy and paste this here. And then the ranks, we have 2, 3, 4, 5, 6, all the way through Jack, Queen, King, Ace. So we can set that up as well. Again, you didn't have to do it this way. This is just so to follow our system along with the workbook. And then probably the most important part was this values. And this values is a nice dictionary where you can pass in the rank of a card and then get out its actual numerical value. This is really useful to us because when we're dealing with cards like Jack, Queen, King, we're not going to be able to directly read off the number itself, such as 2, 3, 4. So what we can do is just use this dictionary as a lookup so we can enter Jack into the values dictionary and get back 10. We'll set Ace right now to 11, but later on we'll deal with that special factor where it can be either a 1 or 11. So we're going to copy this and also paste this here. And then finally, we're going to declare a Boolean value to be used for controlling the while loop. Just like we did in that tic-tac-toe project, it might be nice to have a while loop that's dependent on some variable, such as game on. And in this case, we'll set it as playing is equal to true. So later on at the end, we can set playing equal to false if the game is over. I'm going to run that cell and move on to the class definitions. So what we wanted to do now was create a card class. And the card object actually really only needs two attributes the way we're going to set it up here. It just needs a suit and a rank. And then we want to have a string method on it so that when we actually print a single card, we get back something in the form of 2 of hearts or 3 of clubs. So let's set this up. Here we can see the init method, and we're going to add in 2 attributes, suit and rank. And then we'll assign those. Self.suit is equal to suit, self.rank is equal to rank. And then for the string representation, again, you have a lot of flexibility here, but we're just going to return something like self.rank concatenated with of, notice my spacing there, concatenated with self.suit. So we run that, and now we have a basic card class. And I want to note that it's okay if you either have open close parentheses here or no open close parentheses. It's only when you're using inheritance that you really need them. I usually prefer having the parentheses there. The notebook itself doesn't have them. It's really up to you which styling you prefer. And now we move on to step 3. So for step 3, this is where we wanted to actually store the 52 card objects into some sort of list that we could later shuffle around. And there's already a lot of code that's built out for you here. So we can see what the code is doing. We set self.deck as an empty list. And what's important here to note is even though this deck object has this attribute, self.deck, you can call it really whatever you want, it's not taking it in as a parameter when you actually first initialize an instance of the deck. And that's because when you initialize a deck of cards, you want it to be the same every time. You don't want the user to be able to input a parameter that would make something different with the deck. Instead, a deck should just be a standardized thing. So what we do here is we say, set the deck as an empty list, and then for every suit in suits, remember suits, if we come back up here, that's our global variable, so we're going to be able to access it. For every suit in suits, and then for every rank in ranks, what we're going to do is, like the instructions say here, is actually append these using the card class. We'll say self.deck, so remember that's an empty list, and then I'm going to append using the card class that we defined above. Remember the card class just takes in a suit and a rank. We're going to pass those in as well, suit and rank. And now, after I initialize this, I should have a list of a bunch of card classes. Now for the actual string representation of this, it's really up to you how you want to represent your deck. In our case, we decided to do something like this. And remember, this function only really gets called if you actually print out your deck. So we'll start off the deck composition as an empty string. And we'll say for every card in self.deck, we're going to say that the deck composition, we're going to concatenate a new line. Let's make sure we have our quotes there. Plus the string representation of the card. So remember, card here has its own string representation, and we can call that using the following method. We can say deck composition, new line, plus card, and then string, and to actually execute it, we have open close parentheses here, which basically just calls print out the actual string representation of each individual card. So now we have this giant string with new lines, and at the end, we can just return back a string that says the deck has, and we can add in this deck composition. Then we can shuffle the deck. We actually showed it already here for you, but using that random library that we imported earlier, we just call shuffle on a list, and it will shuffle that list. Notice here, I'm not saying return. This actually happens in place. So this goes back to our discussion of object-oriented programming, where not every single method actually returns something. In this case, we're just shuffling that list in place. Finally, I want to have a deal method, which is a way to actually grab a card from my self.deck attribute, that list of card objects. So we'll say a single card is just equal to self.deck.pop. And this sort of syntax can be confusing for beginners, so I want to take a closer look at it. All we're saying here is basically two things. Grab the deck attribute of this deck class, and then pop off a card item from that list, and then set that to single card. What's confusing sometimes for beginners is that they see these two dots in a row, which is a little weird if you haven't seen it before. But in this case, it is just doing one single method off a list object, just like we did up here, where we said append off this self.deck list attribute, which is this. Once we pop off that single card, we can just return it. And technically, you didn't have to do this in 2 lines. You could have just said return self.deck.pop, but hopefully this commentary helps you understand what's actually happening here. So now we have our deck object ready to go. So let's do a little bit of testing. We should be able to create a test deck and then print out the test deck, which should then print out the deck has and this deck composition that we defined up here. So let's run this. And as you see, deck has 2 of hearts, 3 of hearts, 4 of hearts, 5 of hearts. So notice here, everything is in order. So let's do a little bit of testing by actually shuffling. So we'll say after creating the test deck, grab that test deck and shuffle it. And then instead of printing everything out in order, we should see something printed out shuffled. We run that and we see some diamonds, hearts, clubs, etc. And we can see that it's all been shuffled. So it looks like our deck class is working. All right, let's have a quick review before moving on to the next lecture of what we've done so far. At the very beginning, what we did was we set up some global variables. We also imported the random library. The global variables are a tuple to represent the suits, some ranks, which is another tuple to represent the ranks, as well as values. And this is a really important variable because it's a dictionary lookup where you just pass in the rank and you get back its numerical value so that you can easily take sums of someone's hand. Then we created a class for the card itself. So this represents just a single card, and it has 2 attributes, a suit and a rank, and you can print out a card and it will report back rank of a suit. Then for the deck class, we wanted to leverage that card class in order to quickly create 52 of every single card. To do that, we just have a nested for loop where we say for suit and suits, for rank and ranks, and by creating an empty list for this first attribute, we went ahead and took that list and appended a bunch of cards to it. Remember, that card is an actual card object where we said for every suit in that global variable suits, so that's the one up here, and then for every rank in that global variable ranks, that's the one up there. We went ahead, created a card class, so now we have a card object and we appended it to that list. So self.deck is a list of these card objects. Then we wanted to be able to print out the actual deck, so if you said print deck, you'd get something. And in that case, all we do is we say, okay, start off with an empty string, And then for every card in this list of card objects, go ahead and concatenate a new line and then the string representation of that card. And then we can print out the deck has, and it's just one giant string with a bunch of new line calls. So then when you actually print it out, you get back a list of all the cards. Then we can shuffle the deck, which is basically just calling that random.shuffle method on that self.deck list. And then we have deal, where we pop off a card object and we grab it by returning back that single card. Okay, and then we tested it out by creating a deck, shuffling it, and printing out the test deck. Coming up next, what we're going to work on is creating a hand class and then creating a chips class. We'll see you at the next lecture.